Hello everybody. If you remember the last time we discussed about the chemical formulas and radical, and we understood that how many types of the radicals are there. Now today we're gonna talk about how to name the radicals, or how we will remember which kind of radical having what kind of name. Okay, so first we will start from here, the same name. So many radicals exactly has the same name as the element has. For example, you're seeing over here sodium. Sodium Na plus. It is mono, that means single charge is there, mono, and positive is there, electropositive radical. Mono electropositive radical, it is there, okay, sodium, and the name of this radical is exactly same as the element name is sodium. Similarly, calcium having two, that means dielectropositive. It is also having a name same as calcium. In the way magnesium and the hydrogen and many more are there. So the name actually remains same. Now we need to understand which element name remains same. If you're seeing in the first page of your periodic table in your book, you'll find two groups are there, first group and second group. The sodium and magnesium, hydrogen group and magnesium group, having the same name in it. So you can see this magnesium is also having the same name. Hydrogen is also having the same name. So means the first, second group, whatever the radical it may be, always has the same name. But if you just go little far ahead of that, then you will find a small section, which is a section of transitive transition element. Means the valency is not constant; it changes. And you might be thinking, why the valency changes? The valency must remain constant. But there is a certain element, not certain, a lot of elements are there whose valency actually changes because uh, we have seen in the electronic configuration where the last orbit is remain unfilled. So that's why we call it the remain unfilled electron is basically gives the idea of valency. But what happens with the transition element? Their two shall remain unfilled. That's why their valency changes. So basically, when you're gonna study for in the 11th and 12th, you'll see an entirely different way to calculate the electronic configuration. Okay, but basically, we're gonna understand from this K element. Okay, this kind of shell we're gonna study, but at the later it will change. But just for you kind of information, you must keep in your mind that there is a certain element whose valency changes. If the valency is changing, that means the charge will change. For example, different name, only metallic metals we are talking about, their valency is changing. Fe plus 2, plus means it is electropositive, 2 means it is di-electropositive radical. Here it is plus 3, tri-electropositive radicals. But how you will remember the name? There is a very kind of constant thing or constant idea that will give you a way to remember all the time. Whenever you will find a radical having less charge, they will always have US with it. Ferrous, we know it, ferrous, it will US. If it is having greater charge than that usual, then it will be ferric, IE. Ferrous, ferric. Now move to the next one. You're seeing this, Cu, that is basically a copper. But if it is having single charge, means the least possible charge it can have 1 and maximum it can have 2. So if it is having least positive charge, then it will be copperous, US, like not United States, US, okay, copperous. We will add S. Why we are adding plus 1? Why we are adding plus 1 with US with the plus 1 Cu? And why we are adding Fe, which is having plus 2, but we are adding. Now remember, the least possible charge iron or the ferrum may have plus 2. Least possible charge copper may have plus 1. So least possible charge we're gonna see, least possible, not the number of charge we're gonna see. Least possible ferrous 2 has, copper 2 has. So it will always be ferrous. That means we can understand it is having single, it is having less positive charge. And if it is copper, it is having less positive charge, we will copperous. So US we always apply when the charge is least. Next one is ic. Now you're seeing the ferrous having the 3 charges more than 2, then it will be ferric. And like similarly with the copper having usual positive charge plus 2 it is having, okay, it will be copric or cupric, sorry. It will be cupric. So you can see that there's a formula I have written, two formula. First is FeO, what it is, FeO. You're seeing this, how you can analyze it is ferrous or ferric. Always pull over here, always remember one thing. Whenever we talk about the oxygen, then we're gonna see the number of oxygen, which compound is having number of oxygen more, then it will be in this way. If it is having less number of oxygen, it will be ferrous. It is having less number of oxygen, it will be ferrous. If it is having more number of oxygen, it will be ferric. Now oxygen is there, we will say ferrous oxide, ferric oxide. You're getting the idea probably. Okay, copper is over here. You can see C2O. Now you might be thinking O is remain same in the both case. What is this? No, actually not. Here the oxygen is with 2 copper. Oxygen with the 2 copper, and here is the oxygen with only 1 copper. That means the oxygen proportion is greater over here. We're getting the idea. Okay, so this will be copperous oxide because there is a less oxygen over here, and it will be cupric oxide. So idea is basically clear. When there is a least possible charge is there, we will apply US, and when there is a more possible charge is there, we will apply IC. Okay, so remember this one. Now move to the non-metal. Why we are learning this? The idea why we are learning these things, because one thing you remember always, when we're gonna find out the chemical formulas of name is given, like it will given a name calcium hydroxide. Okay, how you will find the chemical formula, or how you will write the chemical formula through the procedure that we have. Okay, so in this case we need to remember the name of radicals, because in the exam they will not provide you the table that you're seeing in the page 6. They will not provide you the kind of name of the radical has. So you need to remember, and in order to remember the name, you must know what is the short trick, or what are the tricks that will help you to remember the name of the compound. Okay, now move to the some non-metal radicals we are talking about. Non-metal radicals basically which is having charges, they will always contain ide with it. Chlorine we know, it will be chloride. Bromine we know, it will be bromide. Fluorine we know, it will be fluoride, means ide we are using all the time. Sulfur we know, it will be sulfide. Nitrogen we know, it will be nitride, IED. You're seeing this? Oxygen we know, it will be oxide. Iodine we know, it will be iodide. What is this? Phosphorus we know, what will be? Think about this one. Okay, now move to the next. Some other element. What is this? Some other elements like the transition element we have seen, where the valency was changing. In the similar way, some non-metallic also valency changes. And whenever they changes, they never exist in an independent way. They always has the oxygen with it. And in order to, whenever it is having oxygen, the name gets little change. Okay, so when the number of oxygen is less, it will be ITE. We will write ITE when the oxygen number is less. Okay, so it will be sulfide. ITE we will apply. When the oxygen number is more, it will be sulfate. It will be sulfate. ATE we will apply. When the oxygen is less, IT we will apply. And when the oxygen is more, ATE apply. Now remember, this is not a compound. This is a radical. Okay, radical means it can associate with another radical as well. If it is positive, it can associate with the negative radicals. Okay, Move to the next one. You're seeing this phosphorus. What is this? Phosphorus. What it will be the name? Remember, IDE we are adding, then it will be phosphide. So phosphorus will be basically what it will be. It will be phosphite, ITE, because it is having less number of oxygen. And this one will be phosphate, ATE. Now try to answer this one. Nitrogen. Pause the video and think what will be the answer, NO2 and NO3. Now remember, nitrogen is having nitride. So O is with it, then ITE we will add. What will it be? Nitride. Okay. And then if the oxygen number is more, then we add ATE. What the name it will be? Nitrate. So these are the number that you're seeing, the name of that you're seeing in the list, the page number 6 you will find, and the name is given. So for your kind of information, we will again revise this and understand in a very short manner. Okay. So first one is some elements, some metals always contain the same name as the element name is, like sodium, calcium, magnesium, hydrogen. Their radicals also contain the same name. But there are some element whose valency changes and the radicals names will also get different from the element. So if it is +2, then it will be ferrous. When the least number of charge it may have, then we will apply US, and when there is a maximum number of charge, then we will apply ferric, copperous, cupric, cuprous, cupric. Okay. In the same way, non-metal, all the non-metal which is having a charges always carry ide with it. So if it is a chlorine, it will be chloride. If it is bromine, it will be bromide. If it is fluorine, it will be fluoride. If it is nitrogen, then it will be nitride. It will be oxygen, then it will be oxide. So all the non-metal contain one thing, IDE with. Okay, but some non-metals, their valency also changes whenever they are combining with the oxygen. So whenever the least number of oxygen it has, now we cannot decide the least number of oxygen is 1, 2, 3. Different element may have the different number of oxygen. So if it is having the least number of oxygen, any non-metal, it will be ide. We will apply ide. So if it is sulfur, it will be sulfate. If it is sulfur having 4 oxygen number, maximum it is, we will apply 8 sulfate. So in the same case of phosphorus, phosphite and phosphate. Nitrogen having nitride and nitrate. So always remember, when the oxygen is the least amount it is having, ITE, and when it is having maximum amount, we will say 8. So that's a very simple way to remember, and all the elements you are seeing over here, it's very important. Because why it is important? Because most of the question that asked in the exam, like calcium hydroxide, how you'll name this calcium hydroxide. OH name is hydroxide. So calcium is having the same name as it will be calcium hydroxide. So mostly in the exam, the chemical comes, they ask from these chemicals that I've written in the board, and these are the most important chemicals or the radicals you're seeing. Okay, and you must go through the page number 6. So all list of the chemicals are there, radicals are there, which is having the trivalent, divalent, and tetravalent or monovalent are there. So go through it, try to remember, because the next step when we're gonna find out the chemical formula with certain procedure, we need to remember these things. We cannot go and turn the pages all the time and understand this one. So whenever when we are going to understand the chemical formula, how to write down the chemical formula and how to write the names from the chemical formula, we need to remember these things. So do remember and keep studying.